Okay. Oh, shoot. All right, we're talking about parametric functions. Parametric functions. Okay, so parametric functions have this form. This is the simplest kind of parametric function. And so when you think about functions, you should immediately think about what's the independent thing and what's the dependent thing, right? What's the independent quantity that varies? And then what's the corresponding dependent variable that varies according to the independent? So in this case, what is our independent thing or things? What's independent in a parametric function? Kenny knows. Lorenzo. Doesn't have to be time. Yeah, t. So t sometimes is a time, but it's just whatever that t is, right? That t, and it doesn't have to be t either. It could be u, it could be a, but the way I'm defining it here, this little t is the parameter, and that's the independent thing. Okay, that's the independent variable. Okay, what about what's the dependent thing or entity? Yeah.
Looks like both x and y.
Yeah, right. So x and y taken together, right? So given a t, the function generates a corresponding ordered pair of x and y. So how do we graph this? What axis do we put t on normally? What axis do we put t on? Is that the horizontal axis? Yeah? Did anybody learn anything last class? Yeah, Ellen.
Are you talking about the first function or the parametric graph itself?
I'm talking about this parametric function where x is a function of t and y is a function of t.
Okay.
Generally, when we graph it, where does the t go? Where's the axis?
You don't see the t as an axis.
Right, right. Remember this from last time? T doesn't, we don't put t on an axis, right? It's like behind the scenes, right? So instead, we use the normal xy plane, and so now we're just plotting ordered pairs x and y as t varies. So normally, it's displayed on the xy plane. So we could do graphs of x as a function of t and y as a function of t, but that's not the graph of the parametric function, right? The graph of the parametric function is ordered pairs x and y. Still the same xy plane we've always dealt with, but we've got this behind the scenes variable as our independent variable, generating those ordered pairs. And that's what I just said. Okay. So what is the meaning of dy dx, the rate of change of y with respect to x? Okay? So if there were 5 things that I wanted you to know forever after you left this class, this would be in the top 5, or the top 3 maybe even. Given a rate of change, and this is in this case y with respect to x, what does dy dx mean? What's the meaning of that? Tell the person next to you who can do this. Okay, who thinks they can tell me? You remember this? We worked hard on it. Kenny knows. Yeah?
For any small change in x, there is a corresponding change in y equal to 2.5 times as large in this context
2.5 times as large as?
as dx.
Right. So he said, so given a small change in x, there's a corresponding change in y, and that corresponding change in y is 2.5 times the change in x that you picked. Yep, that's it. That's what rate of change means. Given a small change in your independent, this is the multiplier. This is how much greater the change in y is than the change in x, but as in a multiplicative sense, right? Change in y is 2.5 times as much as the change in x. All right, so then what would dx dt mean? And what would dy dt mean? Now that we've got dy dx, okay, so dx dt is the rate of change of x with respect to t. And dy dt is the rate of change of y with respect to t. Tell the person next to you. We're going to get 100% success now. What does dx dt mean and what does dy dt mean? Everybody's talking to somebody if you have to move. If you have to move, you talk to somebody. Okay. Somebody new. Victoria, how'd it go? Okay, tell me. dx dt. It's the small change in t with respect to the change in x. Okay, but what is the dx dt? What is the dx dt? Let's see. How about yeah.
For any small variation in t,
Okay.
x varies by whatever the value is times as much as the change in t.
That's right? So for any small change in t, x will change by this number times as much as that change in t. This is a number. This is a value. It's a rate of change. So that number multiplied by your change in t, or the change in t magnified by this amount, will give you the corresponding change in x. Same with dy dt. Now, when we deal with parametric functions and parametric graphs, all three of these rates of change are significant. Okay? They're all going to come into play in terms of analyzing the functions and analyzing the graphs. Why? Because now x is changing with respect to t, so the rate of change, that's relevant. Y is changing with respect to t. It's relevant. And what? We're graphing in the xy plane. Since we're graphing in the xy plane, changes in y with respect to x are still relevant. Okay? Everything's still relevant. Okay. Any questions? No? Okay, so you're working on that for Wednesday. So let's look at this. I am showing this slider, this n down here, and also this capital T is, we want to turn this on, is our parameter, right? This is the independent variable, t. And I'm going to start varying t, I think from 0 to 2 or 0 to 4. I don't know. Let's see. From 0 to 2. I'm varying t from 0 to 2, and there is some parametric relationship that's giving all the corresponding points as t goes from 0 to 2. So we're going to figure out what that is. We're going to try to figure out what that is. So what does that mean? That means we need all right, so, sorry, 0 to 4. So this is t varying from 0 to 4. So here's t is 0, 0.5, 1, 1.5, 2, 2.5, 3, and 3.5, and 4. So, is it a function? Is this a function? Says no. Says no. No, it's not a function. It's two functions. All right, let's save that question until after we figure it out, okay? We're going to save that question. Hold you in suspense. All right, so what do we need? So we need what x is and what y is. So in order to do that, what we're going to do is we're going to look at t, how it varies, and then try to figure out how x and y vary as t varies, and then from that, try to figure out what's the relationship here that's graphing this set of points. Okay, so we can look at, for instance, t varying from 0 to, say, 1. Oh no, that's way too much. We're going to look at little variations in t. And so as t varies from 0 to 1, so there's 1 right there. So as t varies from 0 to 1, what did x do? How did x vary? As t varied from, let's show you again. We'll just show that part of it. As t varied from 0 to 1, how did x coordinates of those points vary? Boom. So how did x vary? So here's t equals 0. Here's t increasing from 0 to 1. How does x vary? Well, let's do y. Maybe y is a little easier first. How about y? As t varies from 0 to 1. So what does y do? Y coordinates of those points as t varies from 0 to 1. Andrew, what do you think? T varies from 0 to 1, what does that y do? What's that? Uh-huh. What's y right now? Okay, and so then y is varying, and when t reaches 1, y reaches? So y does what? Anthony, what do you think? Why?
Well, as t varies from 0 to 1, y respectively varies from 1 to 0.
He says 1 to 0. That's right. Yeah, it started at 1, and as t varied from 0 to 1, y went from 1 to 0. Maybe that's the easier one. Okay? Now, what did x do? X is a little bit tougher, or a little bit more complex than that. What does the x point coordinates of those points do as t varies from 0 to 1? X starts at 0 and goes to 1 and back to 0. So it does more than what y did, right? So it started at 0 and went to 1 and then went back to 0. Does it make sense? All right, so you're gonna finish the table. So you got t from 0 to 1, t from 1, so then t is going all the way to 4, so you're going to break up changes in t that make sense, and write down the corresponding changes in x. I'm just going to let the animation play. Okay? So here's starting at t equals 1, and you can watch t up there at the top. What does x do as t goes from 1 to 2? McKay?
0 to -1 to 0.
Okay, and y?
0 to
Okay, and then as t goes from 2 to 3. What do we think? Allison, did you get it?
0 to 1 to 0.
Okay. And y?
-1 to 0.
All right, I think we're getting the hang of it here. And 3 to 4. Rithika, what'd you think? Uh-huh. 0 to 0 to positive 1. Okay? So, anyone make headway on now? What is x and what is y? So, here's one thing you might do. Graph x and t and see if you recognize it. So, as t goes from 0 to 1, what did x do? 0 up to 1, back down to 0. And then as t went from 1 to 2, what did x do? 0 down to negative 1, back to 0. 3, up and back down again, down and back up again. So what kind of function is like that? So now we want to write x. So x equals what? Sine of something, right? So sine of something. But if it were truly sine of t, this would be, what would this be? Not 1, but pi, right? And this, when you made it back, it would be 2 pi. So therefore we need? We're going to take t and multiply it by pi. Okay, so let's do this. What about y? So y, then, let's do a different color here. Springtime, use green. All right, so here we go. Y goes from, as t goes from 0 to 1, 1 to 0. Then, 0 to negative 1. Now I'm drawing straight lines, but it's probably curved, right? It's probably curved. 1 to 0. And what is that? Cosine of? No. This at t equals 4 would be what angle for cosine? What angle would that be that where cosine completes one cycle? 2 pi. So 4, t equals 4 has got to give me this thing in parentheses to be 2 pi, right? When t equals 4, I need to complete the cycle or have 2 pi in parentheses. So what does that need to be? Pi halves t. Did anyone figure that x and y out before I started talking about it? Some. Okay, good. About 5 of you. Excellent. All right, so back to my question. Is it a function? Sort of. Is it a function? When you said no, what were you looking at, thinking about? When you said no, I originally asked, most of you said no. You shook your head. Vertical line test, right? Oh, yeah. Fails vertical line test, not a function. All right. Well, what's the vertical line test about? What is that about? It's the vertical line test mimics the requirement of a function. That's what it's really about. It's not just about, oh, does it cross, whatever. So how does the vertical line test show whether it's a function or not? What's the guts behind that? Yeah, Nick. Right. So, and if you're doing the vertical line test, what's the independent variable that you're asking about?
Right now, we should be asking about time.
No, if you're doing the vertical line test, what independent variable are you considering? X. For a given x, there can only be one y. And so if it's crossing in if for a given x you cross more than once, you have more than one y or more than one value of the dependent for the value of the independent. Okay, so that's what the vertical line test is about. Given an x, do you get exactly one y every time? Is it predictable? Is it reliable? Or could you get different things for a value of x? Different y's. So, is this a function? Well, you say yes. What's that? With respect to t, it's a function. What is a function with respect to t? So when you said no, you were correct, but you were correct in that y is not a function of x. Y is not a function of x. Okay? But as a function of t, is this a function? Yeah, and what is a function of t? X and y ordered pairs taken together, because given any one t, how many ordered pairs x and y do you get? Do you get one, or do you get more than one ever? Given a value of t, how many ordered pairs x, y do you get? And does that happen every single time for every t? Do you get just one ordered pair? Yes. No, listen. Given a value of t, how many ordered pairs do you get? So can you get the same dependent value for different values of t? That's okay. That doesn't violate a function. That's like sine or cosine. Sine or cosine. What about 1? You get 1 lots of times. Is it not a function? That's not the criteria. The criteria is given a value of the independent, do you always get exactly one corresponding value of the dependent? You can get that value of the dependent more than once. That's okay. But it's that when you have a particular value of the independent, you need to get just one value of the dependent. And so this thing is a function. Ordered pairs are a function of t. Meaning, choose any t that you want. You're only going to get one ordered pair for that t. You're not going to get more than one ordered pair. Do you see that? So, yes, different values of t could give you the same ordered pair. But that's okay with a function, right? The same person or the same business can have lots of different phone numbers, right? Your phone calls those numbers, takes you to that business. That's a working phone, right? Where's the problem? If you call a number on your phone, and sometimes you get your mom, and sometimes you get your ex, this is the problem, right? That's the problem. That's a non-functioning phone. Okay. Let's try it again. Do another one. All right, I'll start it again. Should I slow? Nah, it's not too fast. Look at t. So that's t starting at 0. I'll start again. Ready? T starts at 0 here. That's where t starts at 0. Watch t up here. Is it a function?
Yes.
Why yes? Why is it a function? I didn't say it loud enough. I didn't jump up and down loud enough. For every value of t, is there exactly one ordered pair that you get? Yes. For every value of t gives you one ordered pair. Is y a function of x? No. Given a value of x, you get multiple values of y, sometimes, at least once. Okay, go. What is this parametric function? I'll slow it down a little bit.
Yeah, it's kind of
Okay, so here's a new one. X is 8t minus 3. Y is minus 6t minus 2. Okay, is it a function? How do you know for sure how it's a function? So be more specific, right? Now we're talking about there's different kinds of functions, right? So how do you know for sure it's a function? What is a function of what? He's saying ordered pairs x, y taken together are a function of t. Is it true? For any given t, do you only get one, for every value of t, do you only get one corresponding ordered pair x and y? Absolutely, right? Absolutely. Okay? And then clearly x is a function of t and y is a function of t. So the question is y a function of x? Is y a function of x? He says no. He says he doesn't know. Okay? So and the one thing I should point out is these parametric functions, looking back at that last one, these parametric functions. So when you normally, before it would have said, no, this is not a function of x, this is not a function, but it is a function. Ordered pairs are a function of the parameter, right? Ordered pairs are a function of t. And so what parametric functions does is it kind of like opens up this whole new universe of curves in the xy plane that are still functions that you didn't think were functions before. If you look at it from the perspective of ordered pairs are a function of t. Okay? So there's that one. There's the one we looked at first. Okay? And really, there's not time, but there's all kinds of crazy curves and things that you can get when you graph something parametrically. And whereas before we would say y is not a function of x, you can graph functions that wrap back on themselves, fail the vertical line test, right? So you can get kind of anything, and still now if you look at it the perspective of ordered pairs are a function of t, it's a function. So you're still looking at a function. Okay, so then the question is, what about this one? So what we can do is, can we get an equation of x and y together here? Can we eliminate t and get an equation of x and y? And then maybe we can answer that question, is y a function of x? So what we can do is, we could look at this and solve this for t. So x plus 3 equals 8t, and what is t? What does then t equal? X plus 3 over 8, is that right? And if t equals x plus 3 over 8, then what does y equal? Negative 6 times x plus 3 over 8 minus 2. So what are we doing? We're eliminating the parameter. We're eliminating the parameter. And so then if we simplify that, we get negative 3/4 x. And what is this? Negative 3/4 times 3. Negative 9/4 and negative 8/4. Isn't that negative 17/4? Did I do the math right? Negative 18. This is negative 9/4. I think that's right. Is that right? Okay. So if you have this parametric function, then the relationship of x and y is that y is negative 3/4 x minus 17/4. So if I graph these, what will happen? If we've done the math right, we should get so does yellow show up? Yellow plus blue equals blue. Let's try yellow plus light blue. Still light blue. Yellow plus red. Yellow's too light. Let's do blue and red. So there's blue. Here's the red one coming. Okay, so is y a function of x? Yeah, because you just get a line, right? You just get a linear function. Y is a linear function of x. Okay, now suppose we had started with this. Suppose we had started with this equation and we wanted to write it parametrically. We wanted to now write now look at what we started with. Is there anything in what we started with that seems like we could get from here to here? That looks like a stretch, right? How in the world did you get this from that? Okay. You can't work backwards because you don't know what x is, right? You don't know what x is in terms of t. So how can we write a parametric version of this? Well, there's an easy way to do that. Do you see what my point is? That if you started with this, how would you get this, right? Who knows? So let's maybe we can write a different parametric version that is a lot easier to attain. So what could we do here? We could just say that x is t. What if we said x was t? Then what would y be? Negative 3/4. Is it a parametric function? Does that fit our form of a parametric function? Yeah. You got x as a function of t, y as a function of t. And so I'm going to turn off the y and x version. And here's the original, and here's that one. So if I turn on this one, x equals t, y equals negative 3/4 t minus 17/4, what will happen? Same line. It's just kind of like indigo. Let's do black. I'll do black. Why is it staying blue? There's purple. Why this black wasn't showing up? Well, I'll turn off the purple one. How about that? Oh, it's not. There we go. Okay, so now my next question for you is, this parametric, this thing that we started with, and this thing, are they the same function? Are they the same function? Yes or no? Are they the same function? Nick, what are you saying? What did you just say?
I said no, because if you plug in an independent variable in one, you get versus the other, you get different versions. So like for t equals 1,
Do 0, do 0.
for t 0, you can get 0 on the new one we made.
Okay.
Negative 3 on the original.
So if you plug in t equals 0, in this function you get what? 0, negative 17/4, right? And what do you got up here?
Negative 3.
Negative 3, negative 2. So does that show that they're not the same function? The same value of t gives different values of the dependent variable. Yeah, that's right. That's correct. They're not the same function because the same t will generate a different point. But what is the same? The range. Remember what the range is of a function? What's the range? What's the range of a function? No, so the range can be different with a parametric function now, right? Because what is the range? It's going to be all possible, not just y values, right? The range is going to be what? All ordered pairs, right? All ordered pairs. It's a set. It's a set. It's going to be all ordered pairs. So what about the range of this versus the range of this? That's the same, right? The ordered pairs that are generated. You don't want to say all real numbers because there's lots of ordered pairs here that aren't in the range of these functions. Only ordered pairs on these lines are in the range. So they're different functions, but they're different functions that result in the same set of points. They're different functions that result in the same set of points. Here's something else that's different about them. But remember we talked about dx dt and dy dt. What's dx dt for this? dx dt is 8. All right, what's dx dt for the other one? What does it mean? What does it mean about, so this is another example of how these functions are different. What does it mean that dx dt here is 8 and dx dt there is 1? Tell the person next to you. Okay, here I'm showing how the points are generated. There's the purple version and the black version. And the t-values are down here. So the t-value is down here in the corner of the screen. Here's the t-value of 0.5. And now increasing 0.6, 0.7, 0.8, 0.9. Okay, so here's -2. T equals -2. So what's happening? How does these dx dt show that they're different functions? I'm flailing here because my slider doesn't work. So for a change in t, our original version, what happens? For a change in t in the original version. Change in x is 8 times the change in t, right? The change in x is 8 times the change in t. And the revised version, given a change in t, you just get a change of 1. So kind of like the rate at which the points are generated. In the first version, points are generated 8 times as fast. Well, the x coordinates change x times as fast as the x coordinates in the second version. And that's, you see that as you change t, you can see that by the kind of like the speed of the points being generated.